Hello again, Lightning Leaders. It is time for part 2 of our addition videos. In the first one, we were looking at different strategies for adding. We did the place value chart, we looked at tape diagrams, which are going to come back when we do word problems, and we looked at the standard algorithm. Now, there are 2 more pages in this packet for addition, and they're just a continuation of what we were doing in the first video, except there's some rounding practice. Now, if you're in my class, you know what's coming next, and I can still, once again, hear all of the groans. It's time for the rounding rap. Now, I am not a singer, I am not a performer. This is going to be laughable, but that's the point. So, before we get started, I'm not even going to look at any of the numbers on the paper. I'm just going to round a random number up here on the board, and we're going to do it together. Let's just start with a random number, I don't know, 7,651. Now, looking at our paper here, we're going to be rounding mostly to the thousands and 10,000s. So let's round this number to the thousands place. We can use the rounding wrap to help us figure this out. Now, if you don't know the rounding wrap, it's pretty funny, and it's a great way to remember how to round. I'm not going to sing the whole thing from start to finish, but I'm going to sing the different parts as we go through our steps here, and so you can see exactly how they come into this. I will put a link to the rounding wrap in Google Classroom so that you can go and watch the full video for yourself and have a good laugh at home and share it with whoever you're doing your schoolwork with at home. So let's start with rounding this number to the thousands place. No matter what number you're rounding, no matter what place value you're rounding to, the steps are always the same. You're only looking at 2 digits in the entire number. That's it. Doesn't matter how big your number gets. But since we're rounding to the thousands place, that's where we're starting. So our first step is to circle that digit. So let's circle it. Circle that place value. Then we move to the right and underline it. So right now, these are the only 2 digits we're looking at. This 5 and 1, we can forget about them. We can forget about them. So now we have a choice to make here. There's 2 more lines from the song that we have to decide which one we're going to use. The first one is 0 to 4, the number stays the same. Or 5 through 9, adding 1 is the game. Now what that means is it's not this 6. It's what we're going to do to this 7. And since this is a 6, it's between that 5 and 9, so adding 1 is going to be our game, which means we need to add a 1 to that 7. So this 7 now becomes an 8. But what about all the other numbers? Well, now we got to finish the rounding wrap. All the other numbers become a 0. You just became a hero in the rounding game. 7,651, rounded to the nearest thousand, is 8,000. I'm going to leave over on the side of the board here our reminders of what to do when we're rounding, so that as we start working through the worksheet, we're going to be able to remember it. So I'm going to put that over here. 0 to 4, the number stays the same. Remember, that is a number sign, not a hashtag. And 5 through 9, adding 1 is the game. Let's look at the first question here. Now, the first example question was done for us on the sheet. And what the directions say is to estimate the sum of each addition problem to check if the student's answer is correct. If not, cross it out and write the correct answer. In the first one, the students said that the answer was 31,998. which turned out to be wrong, because the answer was 11,298. And they estimated that the answer was going to be about 11,000. So we knew right away that the student answer was wrong. Now, thinking back to our math program, the really big word we would use is reasonableness. I know that's a pretty jumbled mouthful, isn't it? We're checking our answers for reasonableness. So let's look here. The first example question is 23,411 plus 35,507. Now again, if you don't know what page we're on, we are on the page labeled Using the Standard Algorithm to Add Greater Numbers, and there is a number 8 in the bottom right-hand corner. And we are on the second question down the page. Now, they want us to figure out if the student answer was correct. And the student answer is 12,918. Well, I don't know about you, but we're adding, and there's no way we can get to a smaller number. So I know right away that it's wrong. But let's do some rounding to prove that it's wrong. We need to round both of these numbers to the 10,000ths place, and then we can add them up. So let's see. Oh man, I gotta tell Miss Whitehan and Miss Loud to stop taking my markers. I need my markers back. Let's look here. Back to the rounding wrap. First step, circle that number. Circle that place value. Move to the right and underline it. We have a 3. 0 to 4, the number stays the same. So this becomes 20,000. Now we can do the same for the next number. Circle that place value. Move to the right. Underline it. 5 through 9, adding 1 is the gain. So we're adding a 1 to that 3. So now our number is 40,000. If we add these two up, we get 60,000. Let's see if the actual number comes out to be close to 60,000. 1 plus 7 is 8. 1 plus 0 is 1. 4 plus 5 is 9. 3 plus 5 is 8. And 3 plus 2 is 5. That's pretty close, isn't it? That's pretty close. So on our worksheets, you would write 58,918 for the answer, for the sum, under the standard algorithm. And then on the right, we would cross off the 12,918, and we would write our estimate problem to the right of that. Let's do one more together, and then I'm going to have you try to finish the page by yourself. And again, just like with the last video, I will put the answers with the work at the end of the video so that you can check all your work when you're done. And if you still have questions, feel free to reach out to any of your teachers and they will be glad to help you. Let's look at the very next question. 72,418. I'm going to get rid of this nonsense, but I'm going to leave my little key over there to help me remember what to do. 72,418 plus 41,291. Now they said that the student answer is 113,709. That's a possibility. Let's do some rounding and find out. Let's see if my purple marker works. Again, we're going to circle that place value, move to the right, underline it. We have a 2, 0 to 4, the number stays the same. All the other numbers become a 0. Okay. Let's do the next one. Circle that place value, move to the right, underline it. 0 to 4, the number stays the same. So we keep our 4. All the other numbers become a 0. So if we add it up, 110,000. It's pretty close to the student answer. Let's see if the student was right. 8 plus 1 is 9. 1 plus 9 is 10. We have a 10, which means we need to bundle and move it over. 1 plus 4 is 5, plus 2 is 7. 2 plus 1 is 3. And 7 plus 4 is 11. So now we have our answer of 113,709 which was the same as the student answer, so that one was correct. Go ahead and finish the rest of the page now. Again, the answers will be put at the end of the video, and if you're still having some trouble, reach out to your teacher, and I know they'll be able to give you some help. Before we finish, though, we're going to jump to page 9 and look at questions 1 and 2. And question 1 says, how does estimating an addition problem help you know if an answer is reasonable? That's a great thing to know as a mathematician. Why did we do this? To figure out if this was going to be right. It's important, especially more with the last example problem we did, because the student got 12,000, but they started with 23,000 and 35,000. Both numbers were bigger than the answer they got, so they knew right away that it was going to be wrong. But by doing some rounding, we can do some quick addition to figure out where our answer should lie, so that, or where our answer should land, so that when we get to it, we can go, oh yeah, I must have done it right because my answer is close to the estimate. It's there to give us a sense of accomplishment. Yeah, we did it right. Or if these numbers are way off, we can go, oh, wait a minute, I did something wrong. I need to go fix this. Now, the second question is, can an answer be incorrect even if it looks reasonable? And, well, yeah. If we had made an addition error here, let's say that we said that, I don't know, we forgot to add this 1, so there was a 6 here, right? Well, 113,000 is so close to 110,000. So if we were just going off of the logic of why to do the rounding and say that, yeah, it's close, our answer is right, we would just move on. So it's also important to double check your work as well. Because, yes, this is going to tell you you're in the right spot, but double checking your actual work is going to make sure that you did it right. Thank you again for joining me for this trip down our rounding review. In the next video, we will be doing some multiplication. See you then.